In this video, we'll move into part 2, where we'll get into all the operations with rational functions. We're always still going to have simplifying at the end, and now we'll move into multiplication. Once again, rational expressions are fractions. So let's actually start off thinking about just fractions of numbers. If we were going to multiply, actually we'll start off quickly, if it's 3 over 4 times 1 over 2, just to get things started quickly. And to remember, the key to multiplying fractions is top times top and bottom times bottom. So 3 times 1, numerator times numerator gives me 3, denominator times denominator gives me 8, and my answer is 3 over 8. But come to the second one, if I have 10 over 27 times 18 over 25, well, if I just blindly multiply 10 times 18, I get 180. 27 times 25, I will get 675. I have this monster fraction, and I'd still have a lot of work in order to simplify it. So the key is to do the simplifying first. How are we going to do the simplifying? Just like we did in the earlier one. We're just going to look for common factors from top and bottom. And it doesn't matter if it's from the numerator here to the denominator here or here to here. If I see a common factor top and bottom, I'm going to cross it off. So 10, if I factor 10, that's 2 times 5. 27, that's 3 times 9. 18, that's 2 times 9. And 25 is 5 times 5. I see a common 5 here and here, I'll cross it off. I see a common 9 here and here, I'll cross it off. What's left, instead of this monster fraction, I have 2 times 2 is 4, and 3 times 5 is 15. That's the idea we want to copy here, folks. When we have rational expressions, yeah, the idea is top times top and bottom times bottom, but more so, the idea is factor so you can cancel those common factors. So now let's move right into problem number 1. We want to multiply x cubed plus 8 over 4x squared minus 16x times x squared minus 16 over 3x plus 6. There's my problem. And as some of you continue to notice, if you are struggling with your factoring, you really just should pause the video, go back, do more work from sections 9, 10, and 11, because you could see how often factoring is coming up. The one nice thing that I could at least say, when we were factoring just a factor, they threw some pretty hard ones in there. Multiple steps, start with GCF, then have difference of squares, a lot of multiple factors. For the most part, as we got to the equations and now the rational expressions, the factoring isn't bad, but you still got to have good ideas. I got to look at x cubed plus 8. I don't see a GCF. I see a perfect cube here and a perfect cube here. That's the sum of cubes. In this one, I see a GCF. In this one, I see difference of squares. In this one, I see a little GCF. We really want to get to that point where, again, you don't have to do it that fast, but that you have good ideas so that you know you're making progress. So now we go through and do it. For some people, again, doing that work off on the side. X cubed plus 8. Well, that's an a cubed plus b cubed with a equal to x and b equal to 2. So my formula goes a plus b, a squared minus ab plus b squared. And now that has a trinomial form, and it's tempting to keep going, but we know from our experience that sum and difference of cubes, that second expression, that's stuck. So we fully factor that, bring that to the numerator here, x plus 2 times x squared minus 2x plus 4. And now I go to this one, the 4x squared minus 16x. I see a GCF. 4 and 16 have a common 4. X squared and x have a common x. 4x came out. Plain x minus 4 left behind. So I come down here and I've got a 4x times x minus 4 times up here, well, x squared minus 16, I'm seeing an a squared minus b squared. A would be x, b would be 4, so this will factor into x minus 4, a minus b, times x plus 4, a plus b. And I bring that up here. This is exactly what I mean, everybody. I could take as much space as I want over here, take my time, do a good job factoring, so that I could bring my clean factors back up here. X minus 4, x plus 4. And then last, the 3x plus 6. Well, that just has a simple 3 that comes out. But that's easy to miss, everybody. As we do more of these problems, not every piece of every fraction will factor, but we're certainly going to be looking for that. And things like this, it's easy to miss. No, a 3 does come out there. We're left with an x plus 2. And now, like we're seeing up here, we're looking to cancel those common factors. That down here, I see this x plus 2 can cancel with that x plus 2. I see this x minus 4 will cancel with this x minus 4. That's all. Again, I can't force it. Some people, they take things too far. It's not just like what we're seeing here with these perfect factors canceling. They see things like this, and they'll, close enough, and cross those off. Nope, those are not the same factor. They don't cancel. So I can only cancel what cancels. What's left? Well, up here when we had numbers, we truly did the 2 times 2 and the 3 times 5. But down here, we'll just put them in the right spot. I've got the x squared minus 2x plus 4, and I still have the x plus 4. So I'll just leave them both on top, still in parentheses, that they are being multiplied. Now in the bottom, I've got a 4x and a 3. I could do that same thing, but that's where that multiplication is so simple. Our book would definitely do that, and we'd finish with a 12x. You can't predict what's going to be left, everybody. You can only do a good job factoring and then just canceling whatever you can cancel. That's it. No prediction to say how many terms will be left. If the terms on top, there's more of them compared to the bottom. You have no idea. You just got to go and do what you can do. Now, number 2, same idea. Number 2, let's look at x squared minus x minus 30 all over x squared minus 25 times 2x squared minus 10x all over 3x cubed minus 15x squared. All right. Once again, initially looks like a big mess, but I need to factor. I need to factor each one of these. This previous one, I did all my factoring work off on the side. In this one, I'm going to do it a little bit more like what I did with the numbers here. I'm just going to work above and below. That over here, I see my grouping number is negative 30. What multiplies to 30 and subtracts to 1? It's going to be 5 and 6. More specifically, it's going to need to be a negative 6 and a positive 5. So I force those in the middle. X squared plus 5x minus 6x minus 30. I'm grouping. First group, x comes out, x plus 5 left behind. Second group, minus 6 comes out, x plus 5 left behind. That becomes an x plus 5 times x minus 6. And already you could see why some people don't like this. Some things factor quickly, like this one. I will just jump and go, oh, a squared minus b squared, a minus b times a plus b. But you can see some people are just working up and down. They're comfortable with it. Others quickly realize, well, sometimes it's nice. Other times it's messy. Maybe they'll save the messy part for the side and they'll just do the quick ones here. It's whatever you're comfortable with. I've got this upstairs, this downstairs in this first fraction. Over here, nothing too crazy. A 2x comes out, x minus 5 left behind. And then down here, a 3x squared will come out, x minus 5 left behind. I've got a lot of options here, but it's still about just canceling those common factors. I see an x plus 5 here and an x plus 5 here. I see an x minus 5 here. I see an x minus 5 here. I could have canceled this x minus 5 with this one. I definitely can't cancel this one with this one. These are both in the denominator. So again, one will cancel with this one in the numerator, but one of them is still going to be left. So I'll cancel this with this. I'll cancel this with this. And now back here, the simple terms, don't miss it. It's easy to miss and say, okay, I've got all the ones in common. But to remember, these are now being treated separately. 2 and 3, well, nothing cancels there. But an x and an x squared, I can cancel this x with 1x here. So what's left? X minus 6 and 2 on top. Just a little more traditional if you have a simple term like that to put it in the front instead of at the end. But still, not actually multiplying, just putting them together. And then in the denominator, I've got that 3, and I've got an x minus 5 left. So that's what I was just saying a moment ago. Up here, we saw some cancellation, a little here, a little there, and we had a lot left. Over here, a lot canceled, and now there's only a little bit left, but you can't control it. You can't cancel things that don't cancel. You could only cancel what does. But the one thing a lot of students certainly notice, if you're doing your work and you don't see anything cancels, something's got to jump out. That either you factored wrong or you're missing something that factors. These types of problems in our class, you should definitely expect at least something will cancel. All right, so that's multiplication. Now we'll move to division. When we do our division, once again, we're still going to start off, just a quick reminder, division of numbers. And I'm actually going to do this just generically, folks, that for division, we either see division of fractions as our traditional left to right, A over B divided by C over D, but to also realize that is the same thing as that. Left to right, A over B divided by C over D. Here, top to bottom, A over B divided by C over D. These are both the same thing. And when it comes to division, for a lot of people, there's an expression they remember that they've been taught: keep, change, flip. Because the real key to division of fractions is that you don't actually divide. You change it to a multiplication problem. Either here, top to bottom, or here, left to right. You keep your first fraction, you change the division to multiplication, and then you flip the last fraction. So A over B divided by C over D is really A over B times D over C. So we're going to realize we're going to do two division problems. And these division problems, they're really just more multiplication practice. So let's divide. And once again, we'll always still have directions to simplify. Let's divide and simplify. Let's start off with a 10x to the fourth over 3x plus 12 over 2x cubed over x squared minus 16. A lot of fractions. First thing, change it to the multiplication problem. Some people are comfortable just right here, and that's fine. Keep, change, and bring this up and flip it. So x squared minus 16 over the 2x cubed. Now from here, a multiplication problem, I'm back to factoring. And this is why some people don't like to do this. Again, that's a dot. It's a times, not a minus. Because now I've kind of lost my ability to come down here. But I've got enough room because in this one, and again, you can't control it. The two previous multiplication problems, we had a lot of factoring. But look at this one. 10x cubed, 2x cubed. They're single terms. There's no factoring those. Those are just done. 3x plus 12, nothing crazy. Just a simple 3 that comes out. X squared minus 16, another difference of square. As we've said before, difference of squares comes up quite a bit. So a lot of people can get very comfortable with it. Still, no shame on doing some work off on the side. But maybe you're comfortable to just jump to the a minus b, a plus b. I see the matching x plus 4s that cancel. And then everywhere else, the simple terms, well, the 10 and the 2, 10 is 2 times 5. A 2 would cancel, 5 left behind. X to the 4th and x cubed, a bunch of x's canceling, or you're dividing x to the 4th divided by x cubed, x to the 4 minus 1. But either way, that's gone. 1x is left here. So what's left? I've got a 5, I've got an x, and I've got an x minus 4. In the bottom, all I've got is a 3. That's it. 5x times x minus 4 all over 3. And I'm just going to keep saying it. You can't control, that there's more on top compared to the bottom or vice versa. It just simply is what it is. And let's do another division now. Number 2, let's do 5x squared minus 8x minus 4 over 5x minus 10 divide by 4x squared minus 8x all over x cubed plus 3x squared. Big warning, everybody. Sometimes people, they see the factoring and they kind of lose their order. They start factoring now, and then they immediately start thinking top and bottom. But what is on the top here is going to become the bottom when I flip to multiplication. So I would strongly recommend, before we do any factoring or thinking, make it the multiplication problem. 5x squared minus 8x minus 4 over 5x minus 10 times x cubed plus 3x squared over 4x squared minus 8x. Now I'll do my factoring, and this is what I've been saying. I look around these, I see GCF, 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 and I see a trinomial. The GCFs are quick. You get good at your GCF, people can come here, 5 comes out, x minus 2 left behind. Over here, 4x comes out, x minus 2. Oh, I'm sorry, folks. I had this backwards. No, it's okay. We'll keep going. Yeah. 4x comes out, x minus 2 comes out here, and over here, and x squared comes out, and an x plus 3 would be left behind. I want to come up and factor this. That's the missing one. But the point that I was making earlier is just this one's a little more complicated. Give myself some room, do it off on the side. Trinomial, I'm looking at the grouping number is negative 20. 5 times negative 4. What multiplies to 20 and subtracts to 8? I'll be methodical this time. 1 and 20. Nope, that subtracts to 19. 2 and 10. There we are. Subtracts to 8. I need it to be a negative 8. So a positive 2 and a negative 10. 5x squared plus 2x minus 10x minus 4. Group here, x out, 5x plus 2. Group here, a minus 2 will come out, 5x plus 2 left behind. 5x plus 2 in common, x minus 2 left behind. So up here, 5x plus 2 times an x minus 2. As we say, whatever cancels, cancels. And this one, it's not really a lot. I've got an x minus 2. Once again, I've got a choice, but it really doesn't matter. It only cancels with one of them. Doesn't matter if you cross this one off or cross this one off. The point is one of the x minus 2's has gone from the top and one has gone from the bottom. Outside of that, well, again, it's easy to miss, but we've just got a little x here. 1x cancels with 1x here, and that's it. What's left? Well, across the top, I still have that 5x plus 2, and I also have this x plus 3. Across the bottom, well, the 5 times 4, that's where, again, when you've got big factors, we'll just leave them. But when you have a simple single term like that, we'll go 5 times 4 is 20. But then I still have the x minus 2. And now again, some people might say it's a tie. This has 2 terms on top and 2 terms on the bottom. But just one more time, that doesn't matter. It doesn't matter what has more terms. It's just simply whatever is left. Here, more stuff was left on top. Here again, it's kind of a tie. But the simple point was we canceled whatever we could, and that's what's left. All right. And now we go to addition and subtraction. And we're going to do these at the same time. Because as we get to addition subtraction, and once again, we're going to go back and just think about some simple numbers. If I had 2/5 plus 1/2, the point of adding, and in a moment, we'll just make this a subtraction problem. The point of adding or subtracting in fractions is all about having a common denominator. Now, ideally, we would like the least common denominator, the LCD. The least common denominator would be ideal. Well, how do I find the common denominator? This is where we'll start with a basic one, and then we'll come to a second example with numbers and expand and see how that applies to our rational expressions. And in this first one, we're going to realize in a moment one of the keys is that these are already prime, they're already factored, and that 2 times 5 would give me 10. The common denominator is 10. What do I do to establish that common denominator? Well, whatever I do to the bottom, I have to do that to the top to keep everything balanced. So how do I make this into a 10? I'll multiply by a 2. And then whatever I do to the bottom, I do to the top. Over here, well, I'd make this a 10 by multiplying by 5. And whatever I do to the bottom, I do to the top. This first one just became 4 over 10. This second one is 5 over 10. And 4 over 10 plus 5 over 10 is 9 over 10. Now, some people would just say, okay, he multiplied the denominators together, but that's where in a moment we'll realize factoring is a bigger key here. But before we get to that part, what if it was 2/5 minus 1/2? Same thing, everybody. I'd still get that common denominator. I'd still do the same work. I'd have 4 over 10 minus 5 over 10. Once I had the common denominator, the key was the denominator stayed, and I did the arithmetic across the top. 4 plus 5 is 9. That's the same thing here. Just this time it's 4 minus 5. I'll get minus 1 over 10. But this is where, before we start getting to the rational expressions and sticking variables in here, let's come back and realize that getting that common denominator, sometimes it can be that simple. But let's look at a second example. If I had 5 over 8 minus 1 over 4. If people just see I multiply the denominators together, well, here 4 times 8 is 32, and that's the common denominator. But if we realize, especially focusing on this idea of least, what we're really doing is thinking about the multiples of the denominator and trying to find the smallest one. And if I come over here, 4 times 2 is 8. That's all I need. Instead of doing this one times a 4 over 4 and this one times an 8 over 8, the better way, because we are still going to want to simplify at the end, the better way to make our life as easy as possible is to get the smallest common denominator. That would just be multiplying this one by 2. That would give me the 8 here, and I already had the 8 here. This will become minus a 2 over 8, and now 5 minus 2 is 3, so my final answer would be 3 over 8. But how are we going to connect this back to these algebraic expressions, these rational expressions? We would come back over here and we'd realize the key was that this could be factored into 2 times 4. They both have the common 4. This one has an extra 2 that this one is missing. So let's just get that extra 2 in place. Okay, now let's see how that works with algebraic expressions, how it's the same, but how we get used to it. So let's start off, number 1, with 3 over x plus 4 minus 2 over x plus 1. This is the version that's just like this. The x plus 4 and the x plus 1 are as basic as they're going to get. There's no factoring there. So that's like the 5 and the 2. There's no breaking those down any further. Not with whole numbers anyway. 5 is 1 times 5. That's all we got. So like this one, the common denominator would be x plus 4 times x plus 1. Just like this common denominator was 10, which was really 2 times 5. My common denominator, I'll write CD, is x plus 4 times x plus 1. And now I go to each one. What are they missing? Well, this is missing the x plus 1. Well, I can't just do that to the denominator. I'd have to do it to the numerator as well. Keep everything balanced. This is missing the x plus 4. But once again, whatever I do to the denominator, I do to the numerator. Some people, once they get that same denominator, instead of keeping them separate, they'd like to just write it as one big fraction. The 10 is going to stay, so let's do the arithmetic up top. So I'll show you that here, but 2 steps. First step, like we saw here, yeah, the 2 times 5 gave me the 10, but I also had to do 2 times the top. Over here, I'm not going to multiply x plus 1 times x plus 4. I'm just going to leave them together to see that common denominator. But up top, 3 times x plus 1 is 3x plus 3. Minus. Over here, same thing. I've got the x plus 1, x plus 4 in the denominator. And now some people, 2 different ways to look at it. For right now, I'll just distribute the 2. 2 times x plus 4 is 2x plus 8. And in a moment, we'll realize this negative needs to be distributed to both terms. Other people, they see that subtraction, and they'd rather think of it as a plus here and put the negative on the 2 so that this is a plus, and we're automatically distributing that as a negative 2, and we get negative 2x minus 8. But now, up here, I did my addition or my subtraction across the top, and the denominator stayed. Now, it's about like terms. The denominator is done. It still stays x plus 1 times x plus 4. On top, well, 3x minus 2x is 1x, and 3 minus 8 is minus 5. I'm left with a 1x minus 5 or an x minus 5, and there's no good reason for me to multiply these together. Just like we saw with the multiplication and division, we actually would prefer that you just leave it factored. Because this one is done, but what happens is at the end of the problem, we'd have to be a little careful. Does this have any factors that would eventually cancel? Well, in this one, x minus 5, it's done. There's no factoring, and it doesn't match either, so nothing extra cancels. So now let's jump to a second one that's a little more similar to this. If I had 4 over 8x plus 3 over 4x squared. And once again, if you take the wrong approach, you just go 4x squared here and an 8x here, and you end up with a gigantic mess, especially in this problem. So once again, let's be strategic. Let's realize that 8 is really 2 times 4, and x squared is really x times x. So I've really got a 2 times 4x here, and I've got a 4 times xx here. The first one, it's missing one of the x's. I'll do an x on top and bottom. The second one, I'm missing the 2. So I'll do a 2 on top and bottom. I've got the 8x times x is an 8x squared. 4x squared times 2 is an 8x squared. I'm just going to make one denominator now because I see it's the same. And then on top, well, I've got a 4x here, and I've got a plus 6 here. What can I do? Well, there's no like term, so that part is done. But at the end of this is the tiny little catch at the end. It feels like I'm kind of done here the way I was done here, but just at the end to notice, this top can factor a little bit. A 2 can come out, 2x plus 3 left behind, and that 2 can divide into that 8 with a 4. So my final answer would be 2x plus 3 over 4x squared. So in this one, try to be a little more clear on being strategic to get the common denominator, but then we realize we're not always going to get like terms like we did here, and whether we do or we don't, we always have the possibility of a little factoring at the end to clean up this expression a little bit. All right, let's do two more. Let's look at quantity 7x plus 1 over x squared minus 25 plus 4 over x plus 5. And now we're starting to get a bigger taste of these problems. Simple denominators, both factored, pretty quick to get common denominator. These a little bit messier, but we could break it apart to find that common denominator, what was missing. Similarly here, I look at this, that's factored, but this one is not. And if I factor it, another difference of squares, I'll see an x minus 5, x plus 5. And now similar to what we were seeing here, instead of just blindly multiplying all this here and this over here and making a really big mess this time, we just realize what's missing. This is missing the x minus 5. And that's it. So I'll multiply top and bottom by x minus 5. Now I've got the common denominator. I've got an x minus 5, x plus 5. This one was already done, so the 7x plus 1 just comes over. Over here, to get that common denominator, we had to multiply by x minus 5. Let's do that here. Let's distribute that 4. I've got a positive in front, so a positive 4 times x is a positive 4x. A positive 4 times negative 5 is negative 20. And now I'm just collecting my like terms. 7x plus 4x is 11x. 1 minus 20 is minus 19. And it's still over the x minus 5, x plus 5. I take one quick moment. Can I do more with this? Sorry, with this. This is already factored. Can I factor that? I cannot. So that is my final answer. And now last one. Last one for this section. Let's look at 5 over x plus 2 plus x minus 4 over x squared minus 2x minus 8. Again, I see some denominators. This one is clean. This one is not. Let's get to this one. Let's break this apart. I see a grouping number. Again, maybe up here that was quick. So just a simple a minus b, a plus b. Over here, maybe do a little work off on the side. I've got a minus 8 as my grouping number. What multiplies to 8 and subtracts to 2? Well, that would be 4 and 2. The 4 will need to be negative, the 2 positive. That'll become x squared plus 2x minus 4x minus 8. As I group, x out, x plus 2 left behind, minus 4 out, x plus 2 left behind. And now I'll just take that answer right here, finishing the x plus 2 comes out, and the x minus 4 is left behind. And now we can see this problem is pretty similar to this problem. This is missing the x minus 4, so I'll multiply top and bottom by x minus 4. Sneak that in down here. I've got the x plus 2, x minus 4 in my denominator. Right here, distributing my 5, I get a 5x minus 20. And over here, I have that plus x minus 4. Like terms, 5x plus x is 6x. Minus 20 minus 4 is minus 24 over the x plus 2, x minus 4. And this is where, folks, it's so easy to feel good and feel like we're done, but at the end, still have that moment. Can I do a little more up here? And this time I can. A 6 can come out, x minus 4 left behind, x minus 4s would cancel. The real final answer would just be 6 over x plus 2.